Hey guys, we're going to finish the multiple choice here just because we ran into time in class. Okay, so the histogram below is 750 high school, right? So that means our population number, that's our big N, is 750, all right? So we know using the 10% rule that our sample size has to be smaller than 1/10 of our population. So that would be 1/10 of 750 would be 75. So N has to be less than 75. And so that's why we see that right here. And again, sometimes you'll see it'd be fine if it's less than or equal to, right? Now here, I'm taking on data, right? And so that's why, even though this is skewed data, and we talked about this flow chart, okay, it's skewed data, but as long as N is greater than 30, the central limit theorem tells us that our sampling distribution would be normal. So this is creating kind of a lower bound and an upper bound for us to be able to say that we can perform normal calculations on this distribution. Pretty neat, right? All right, let's take a look at 7. It says, income of a certain population of college teachers have a normal distribution. All right, so it is normal, mean standard deviation. 4 teachers are selected to serve on a salary review. What is the probability that they're average? All right, so if their mean is 6,000, then their standard deviation would be 5,000 divided by the square root of 4, which is just 2. So half of that would be that. All right, so we have our data here. So what would be the probability that it exceeds 65,000? So we just need our app, right? Now I have started teaching you. If we use the calculator, our normal CDF calculator would say, give me your lower bound, give me your upper bound, give me your mean and your standard deviation, right? My lower bound is 65,000. My upper bound is just a really, really big number. My mean and my standard deviation. So if we put this into a calculator, let's see if I still have my calculator. Yeah, all right, so my mean is 60. Standard deviation. And I need anything above 65,000. And I get the probability 0.0228. 0.0228. And there we have it. Our answer is 0.0228. Question number 8. A random sample size of 25 was taken from a population that is normally distributed. So now that we know that it's normally distributed, it doesn't really matter the size of N, our sampling distribution will be approximately normal. Okay, so even though 25 is less than 30, we're good. The mean is 60 and our standard deviation is 10. The mean X bar of the observations in our sample is to be computed. The sampling distribution of X bar would be, oh, this is interesting. This is like our Khan Academy. It actually doesn't say approximately. It says it is normal. So this would be the one time that we could say that it's going to be normal. Interesting. I don't like to do that. I like to kind of stray away from that, but I could say that. We know our mean's going to stay the same. And again, we know our standard deviation of our sample would be sigma over the square root of N. So the standard deviation of our sample and the square root of 25 is 5. And so 10 divided by is 2. So our answer would be B. Cool. Okay. 9. The scores of individual students in a college entrance exam have a left skewed, with a mean and a standard deviation of 6. At Millard Northeast High, 36 seniors took the test. Okay, so my population is, my big N, right, is 36. The sampling distribution of mean scores for a random sample of 36 students. Oh, no. Okay, I misread that, I guess. This would be our sample size, okay? So since 36 is greater than 30, thinking back on our chart, so since the data is skewed, but it's greater than 30, the central limit theorem will state that the sampling distribution should be approximately normal. So we choose A, approximately normal. Okay, question number 10. The distribution of prices for home sales in Minnesota is skewed right, with a mean and a standard deviation given. Suppose you take a random sample of 100 homes, okay? From this, very large, so it's saying N is huge, okay? So our 10% condition is met. What is the probability that the mean sample is above 325? Okay, so our mean would be the same mean. And our standard deviation would be that. Divide by the square root of 100, which is dividing by 10, which would just move the decimal. All right. And I want to place this somewhere above 325,000. So I need my area under the curve. All right, so before my iPad dies, let's find this out. So above 325, my mean, or excuse me, my standard deviation. I got to go back. I can't remember it. So my mean was 290, 1450, 325. 290, 1450, 325. 290, 1450, 325. Calculate this. I'm getting nothing. Oh, I left out a 0. That's gonna make a difference. Okay, yeah. So our picture says 0.0079. 0.0079. Our answer is C, 0.0079. Awesome, guys. Thanks for joining us. That's just the multiple choice to finish it off for the test next class. Good luck.